Hello and welcome to 6 of ABG discussion. We were discussing about various problems on ABG. So let's consider another one. If pH is 7.25 and PCO2 is 60, PO2 of 58 and bicarb of 26. What's the sodium? Sodium is 140 and chloride is 105. So first step is anion gap. Anion gap would be 140 minus 131, which is 9. So delta gap would be less than 0. So there is no anion gap metabolic acidosis. Let's see what is happening now. pH and PCO2 are going in different direction. pH is decreasing, PCO2 is increasing. So this means that this is a respiratory phenomenon. Since pH is decreasing, this is acidosis. And what will decide if it's acute or chronic? Let us see what is happening to bicarb and PCO2. Okay, so PCO2 has gone up by 20 units. And bicarb has gone up by 2 units. From 24 to 26 it's 2, and from 40 to 60 it is 20. So that's close to 1 by 10, which goes more in favor of acute respiratory acidosis. Okay, let's go on to the other one. Right, so pH is 7.33, PCO2 is again 60, PO2 of 55, and bicarb of 30. Sodium 140 and chloride 102. Right, first step is calculate anion gap. Anion gap would be 140 minus 132, so that is 8, which is pretty normal. Delta gap would be again less than 0 or 0, so we don't have an anion gap metabolic acidosis here. Now pH and PCO2 are going in different directions, so that's a respiratory mechanism. And since pH is less than 7.4, it is respiratory acidosis. Let us see whether it is acute or chronic. Go for bicarb and PCO2. Now PCO2 has changed by 20 units, and bicarb, see, now bicarb from 24 it has gone up to 30, so that has changed by 6 units. So that's close to 1 by 3, which is chronic respiratory acidosis, if you remember your Winter's formula. So Winter's formula helps in deciding whether it is acute or chronic acidosis and whether there is any compensation or not, and whether there are any multiple metabolic or respiratory problems in the same patient. Okay, so since pH and PCO2 are going in different directions, it is respiratory. pH is less than 7.4, it is acidosis, and since the compensation has kicked in, so this is chronic respiratory acidosis. Right, let us go and check the next question. So pH is 7.23, PCO2 is 27, beg your pardon, 27, PO2 is 99, and bicarbs are 12. Sodium is 142 and chloride is 96. Right, so the first thing to do is calculate the anion gap. Now anion gap would be 140 minus sum of bicarb and chloride. So anion gap here is 140 minus 96 plus 12. So that's a huge anion gap of 32. Right. So there is an anion gap metabolic acidosis. This is the first diagnosis on ABG, anion gap metabolic acidosis. Okay. What is the delta gap? Delta gap is anion gap minus the present anion gap. So that's 32 minus 12, which is 20. Right. So what does it mean? It means that whatever weak acid was added to the body, it has released 20 protons. Okay, and it has released 20 negatively charged bodies, which are contributing to increased anion gap. So those 20 protons were buffered by 20 bicarbs. Okay, so if we add delta gap to our present bicarb, should be 24. See what it is now? It is 20 plus 12 is 32. So that means, see, ideally your bicarb should have been dropped by 20 units. So bicarb should be 4, because whatever weak acid was added to the body, it has released 20 protons and 20 negatively charged bodies, and 20 negatively charged ions have contributed to increased anion gap. 20 protons which were released have been buffered by 20 bicarbs. So bicarb, if 24 is normal, then it should drop by 20 units. It should come down to 4. Rather than that, it is 12. So that means there is a process through which body is gaining bicarbs. So this patient has got metabolic alkalosis as well. Okay, so since this patient has metabolic acidosis, let us see what Winter's formula says about this. Bicarb by PCO2. Now bicarb has dropped from 24 to 12, which is 12 units, and PCO2 has dropped from 40 to 27, which is 13 units. It is pretty much close to 1 by 1. So this is a picture of anion gap metabolic acidosis and metabolic alkalosis. Okay, let's go on to next question. Right, so pH is 7.26, PCO2 is 27, PO2 is 99, bicarb is 12, sodium is 140, chloride is 118. Okay, so first step, anion gap. Now anion gap is 140 minus 130. So that's 10 in this case. Okay, so anion gap is normal. So there is no anion gap acidosis. But since pH, so delta gap would be again less than 0. Now pH and PCO2 are going in same direction. pH is decreasing, PCO2 is decreasing. So pH and PCO2 are going in same direction. So this is of course a metabolic process, and since pH is going low, it is acidosis. But it is not wide anion gap acidosis. So this is normal anion gap acidosis. Okay, let us see Winter's formula in this. PCO2 bicarb has dropped by 12 units, PCO2 has dropped by 13 units, which is closer to 1 by 1. So which is pretty much a straightforward normal anion gap metabolic acidosis.